The vast expanse of our country experiences wide variations in climatic conditions. The temperature varies from minus 50 degrees Celsius to plus 50 degrees Celsius. Moreover, our huge coastline provides highly corrosive environment. To ensure proper working of various equipment in such diverse conditions, the equipment is subjected to certain simulated environmental tests. The environmental tests help in checking the suitability of equipment with respect to humidity, temperature changes, bumps, vibrations, static discharge, electromagnetic interference, etc. This program deals with environmental testing of electronic equipment humidity test. This test is performed to determine the effects of high humidity at constant temperature over a prescribed period. The equipment to be tested is placed in the test chamber. Proper care is taken to avoid formation of water droplets on the equipment as it is introduced into the chamber. The chamber temperature is maintained at 40 plus minus 2 degrees Celsius and with a relative humidity of 93 plus minus 2%. The equipment is kept under test conditions for 4, 10, 21 or 56 days depending on relevant specifications. The record of chamber conditions is taken on a graph. Dry heat and cold test. Dry heat and cold test is conducted to determine the suitability of an equipment for use at high or low temperatures. The equipment is placed in a chamber which is capable of maintaining the temperatures from 40 degrees Celsius to 200 degrees Celsius with a tolerance of plus minus 2 degrees for dry heat test and up to minus 65 degrees Celsius for cold test. In this case, the chamber is programmed for a dry heat test. The chamber temperature gradually rises up to 70 degrees Celsius, which is the specified temperature for the equipment under test. And for conducting cold test, the chamber is once again programmed. This time, the chamber is programmed for minus 55 degrees Celsius. The chamber temperature falls gradually up to -55 degrees Celsius. The equipment is kept at the appropriate temperature for 16 hours unless otherwise specified. The chamber conditions are plotted on a graph for record. Bump test. Bump test is intended to determine the suitability of the equipment for transport or use in applications where it may be subjected to repeated shocks, such as those that occur in vehicles traversing through rough roads. The equipment to be tested is mounted on the bump test machine. It is then tightly clamped onto the platform. The rate at which the bumps are to be given are set on the machine. Successive bumps are then given to equipment under test. The total number of bumps vary from equipment to equipment. Vibration test. Vibration is regarded as a major cause of equipment failure. The equipment faces vibrations during transportation initially, or it may occur due to installation in environment full of vibrations. For conducting this test, the equipment is mounted on a computer-controlled vibrating platform. A transducer is fixed for making the system a closed-loop one. Once through with the mounting, the machine is programmed for specified number and time of vibrations. For giving vibrations in horizontal direction, the equipment is placed on a horizontal platform. It is then securely tightened. A transducer is once again fixed for sensing vibrations of the equipment under test. After mounting the equipment, the number and time of vibrations is fed into the machine. The test is performed in accordance with the standard specifications, which may vary depending upon application. Surge test. This test is conducted to determine the effect of lightning or switching surge on the equipment. The equipment is given AC main supply through the surge tester. The equipment under test is switched for performing test in on condition. The surge can be either positive or negative. At first, positive surge of specified voltage and duration is superimposed on the mains supply of the equipment, and the peak open circuit kilovolts are noted. In the next step, negative surge is given to note the behavior under negative surge conditions. Static discharge test. While handling static sensitive electronic devices, a static charge detector is used for detecting static charge in the vicinity of the devices. It gives a beep when static charge is present in the vicinity of the work area. The job should be performed only when there is no beep. Electromagnetic interference test. This test is conducted to find the electromagnetic interference produced by an equipment while in operation. The equipment to be tested is placed on a rotary platform which is rotated by 10 degrees in a step so as to measure electromagnetic interference from all sides of the equipment. The equipment is energized and placed in front of an antenna. This antenna is capable of moving in two directions, upwards and downwards. During the upward and downward movement of the antenna, the maximum electromagnetic interference caused by the equipment is determined. And this maximum interference from all sides of the equipment should be within the permissible limits as specified, which may vary from equipment to equipment. All these environmental tests assess the durability of electronic equipment under various conditions of use, transport and storage.